Kia ora koutou, Year 9. This is a request for Daniel for some more questions for some find ones, like the ones that we did near the end of last week. So if you're watching this, this is pretty much at relational to extended abstract level. And the method I'm going to use here is one that we're going to drop in about another couple of weeks' time. The big idea here is that I'm looking at what I've got on both sides of the equation, and I'm using a matching up technique. Okay, so we're using all of the stuff we've done in this topic on expanding and working with powers and working with simple algebraic fractions. So let's start out, and the questions get harder here as we go. So the first one is at relational level. We've got 2x times 5x squared times 2y cubed is equal to 10y squared p. So here what we're being asked to do is to find the value of p. In other words, p is going to be an expression. It's going to have numbers in it, x's and y's. So the first step is to clean up all of the mess we've got on the left-hand side here, right? So this is the left-hand side of the equation. Working first with the numbers, I get 2 times 5 times 2, which gives me 20. And now I've got x times x squared. So that's x to the power of 3, because the bases are the same. And when the bases are the same, that means that I can add the powers. We've got an invisible 1 here. X is the same as x to the power of 1. And then we've got times y cubed. So now I've cleaned it up, I've dropped my multiplication signs, and I can see that I've got 20x cubed y cubed is equal to 10y squared p. And you can kind of think of p as being like a big picnic basket that you've got all of your stuff inside. And now we need to figure out what is in the picnic basket. So we can draw it as a box. And I know that some of you won't need to do it this way, but I think when you're starting out thinking about this, it's not too bad a way to visualize it. So looking now over here, and then looking over here, you can see, what do I need to times in by? Well, to match up with the 20, I need to times by 2. I've got no x's so far, so I need to times by x cubed. And I need to end up with y cubed. So far I've only got y squared, so I need another y. So that means that in this case, p is equal to 2x cubed y. That's the first one done. Let's look at question 2. Oh yeah, I chucked in some brackets in here to give you some practice with just what we do with brackets. I could have put some negative signs in, I've just realized that, but that's okay. Too late now. Okay, so question 2 says we've got 5x in brackets squared times 2y cubed, and that's the same as 5p y to the power of 5. So again, we're going to clean up what we've got here. We've got 25x squared times 2y cubed is equal to 5p y to the power of 5. So I'm not really looking at this right hand side just yet. First of all, I'm saying that over here I've got 50x squared y cubed, and that's the same as 5y to the power of 5 times whatever's in the picnic basket. And now we'll work out what that is. So p has to have 10 times y squared, right, to match up this, times another y squared, right, because here I've got y cubed. Oh no, hang on, that's not right. I've done that the wrong way. Let's have another look. This one is different. I want to end up with y cubed, but I've got y to the power of 5, right? So I've got too many of them, so I have to divide them out. So I'm dividing by y squared. Now, what do we end up with? Well, we want to clean this up because that's just kind of gross with the times and the separate numbers. So p in this case is equal to 10x squared over y squared. And we can check that we've got that right. And when we start getting to the harder ones, it's probably worth doing. Let's see. I'm going to go back now and I'm going to substitute in my answer for p and see if it matches up to what we got on the left hand side. So we want to end up with 50x squared y cubed. So let's try it out. 5 times p, 10x squared over y squared, times y to the power of 5 will give me 50x squared y cubed. Okay, so big smiley face. That looks good. All right, on to the next two. In question 3, I put in some multiplying fractions, and in question 4, I put in some adding fractions, just to give people watching some practice at all of that algebraic fraction work that you did in the Gamma textbook. So in question 3, we've got 6x squared over 7 times 14 over y is equal to 5p y to the power of 5. When I'm multiplying fractions when there's algebra, it works just like it does when there are just numbers. Right? I times the top and I times the bottom. But here we can simplify through the fraction first. We've got a common factor of 7 here, so that simplifies to just 2 wholes. On the left-hand side, I've got 12x squared over y is equal to 5p y to the power of 5. Right, so once you've got fractions involved, you do have to slow down a bit and think about what you're doing. So here we've got 12x squared over y is equal to 5y to the power of 5 times p here. Now p is going to be a fraction. Let's think about what we want to have in it that we don't have yet. Well, we want to have a 12 and we want to have an x squared. So we're going to times those in. And we want to end up with, so the 12x squared is good. We don't want the 5, so we divide out by it. And we want to end up with divided by y. At the moment, we've got y to the power of 5. So here we need to have y to the power of 6. And if you just stop and take a look at what you've got, you'll see that that's going to work out, right? I'll just change pen color so that we can see. So you can see that the 5 and the 5 will go. I'm going to be left with the 12x squared, and this will simplify down to y. So that's all looking like that's how we want it. So let's just magically undo all of those dividing out things. Oh, it would be, imagine if you could do this in real life. Right, there we go. So that looks like that's what p is going to be. So p in this question will equal 12x squared. Oh, I've got an extra y popped up in there. 12x squared over 5y to the power of 6. And now we can check it and we can see if it works. And if we do that, we get 5y to the 5 times 12x squared over 5y to the 6th. And we can see that the 5's go. This goes and leaves me with y, and I get 12x squared over y, which is what we wanted. Right, one more to do, and then that'll do. This one has got some adding fractions work in it. And again, the thing we're going to end up with will be a fraction to make everything work out. Just get a wee bit of space here first. So you should try it before I do it. So let's just try adding the fractions on the left-hand side. We've got 6x plus over 5 plus 3x over 2. We need to get a common denominator, which will be 10. Right, 5 watts are 10, 5 2's are 10, so this becomes 12x. 2 watts are 10, 2 5's are 10, so this becomes plus 15x. That gives me 17x over 10. So what I'm trying to work out is 17x over 10 is equal to something x squared over 4. All right, we're going to use the same slow matching up method that we did before. So let's write it out slowly. 17x over 10 is equal to x squared divided by 4 times something. Now, we don't want the 4 in here, so we're going to times it out. We don't want the x squared in here, so I might start by timesing that out. And then I do want 17x, and I do want 10. So if we simplify all of that, we'll get 2/5 here. So we get 34 over, let's see, 34 over 5x, because I have x here and x squared here. So that gives me p is equal to 34 over 5x. Now let's check that when we times this by x squared on 4, we get back to the left-hand side. Remember, our target is to get 17x over 10, because we know that that's what that is. So let's try it out. Px squared over 4. So if we think that p is equal to 34 over 5x, p times x squared over 4 equals 34 over 5x times x squared over 4, which is equal to, let me have a look. Okay, so here we've got 17 and 2, and here we've got x squared and x. So we've got 17x over 10, which is equal to what we simplified the left-hand side to. So that looks good. All right, so there you go. That's a slow way to do those questions. Some of you, I know how to solve equations using inverse operations already, and it's totally fine to do those questions using that method. In fact, I'm just going to quickly whoosh through a couple of those using that method, just in case you're worried. We just want to see logical, clear working. We don't mind how you think about this, whether you think about it as someone who can already confidently solve equations or what. So in question 1, doing this the fast way, y squared p, I'm still going to clean up the left-hand side, and I'd get 20x cubed y cubed is equal to 10y squared p. Now I'm going to do the same thing to both sides, and I'm going to divide both sides by 10y squared. So that gives me straight away p is equal to 20x cubed y cubed divided by 10y squared, which equals 2x cubed y. All right, so it is much, much faster. In question 2, if we do it that way, let's see what we get. Right, question 2. 5x squared times 2y cubed is equal to 5p y to the 5. Cleaning up on the left again, we get 25x squared times 2y cubed equals 5y to the 5 times p. 50x squared y cubed divided by 5y to the 5 is equal to p. So p will equal 10x squared over y squared, and so on. I'm not going to do, let's see, I have got time actually to do the last couple, doing it that way. So 6x squared over 7, 6 squared over 7 times 14 over y is equal to 5p y to the 5. Cleaning this up first, I get 2 here, so I get 12x squared over y is equal to 5y to the power of 5p, and I'm going to divide both sides through by this. So 12x squared y times 1 over 5y to the 5 is equal to p. We get 12x squared over 5y to the 6th is equal to p. And the same thing works for the last one. Now, some of you watching this, or possibly parents who are watching this, are probably going, why the heck didn't you just teach everyone this method first? And my answer to that is that we really want students to be very, very confident with the idea of matching things up on both sides, and then we move on to teaching them inverse operations. So the idea of solving equations is something that we'll get to at the end of this topic, but the focus in our first algebra topic has been on manipulating expressions rather than looking for the value of something that makes something true. And at the very end of this topic, those two ideas start to link up. Okay, guys, that's probably all the Year 9 videos from me for today, unless there are any last-minute requests. Hope some of you get to see this in time, and good luck for the test tomorrow.